Hi everyone, this is Algebra 2, Chapter 4.5, as well as Chapter 4.6. We're going to be looking at evaluating functions, linear and quadratic or cubic. So where I'm at is I'm up here at the top. So there's two different functions taking place here. There is this function, and let me go ahead and make this a little bit bigger. There's this function, and then there's this function. For f of x equals negative 2x cubed minus 5, it tells me that right here is what my x equals. And then for the other equation, or function I should say, is this tells me what my g is. So this is basically a review. We've done this. The only thing is we've done it with x squared. Now we're doing x to the third power. So this is f of negative 3 equals negative 2 times negative 3 cubed minus 5. And this is where order of operations comes into effect. So what this is saying is negative 2, and I'm just going to break it out to you so that you understand what negative 3 cubed is. Negative 3 times negative 3 times negative 3 minus 5. And what that equals is negative 2. And so if I did negative 3 cubed, that would give me negative 27 minus 5. Give myself some room here. We're continuing with order operations. I have to do multiplication. Negative 2 times negative 27. That gives me 54 minus 5. Thus, my solution is 49. 49. Again, this is all review. We have done this. We've been tested on it. The only thing different here is that it's cubed right there. Go ahead and do the function of g of x equals negative 3x plus 2. You're going to utilize everything in blue there to help you solve. If you notice, this is not cubed. This is just x to the first power. In other words, you're just going to replace that x value with 7. Moving on here, it says finding where a function is increasing, decreasing, or constant given the graph. We've done this as well, but things I want to highlight for you. It says here, write your answer as an interval or a list of intervals. When you see intervals, what that's telling you, and write this down so you don't forget, is it represents your x values. Again, your x values. So if writing a list, separate with commas, write none if applicable. So let's read our first portion right here. It says determine the intervals on which the function is strictly decreasing. Okay. Well, over here on my graph, my grid, I want to look at where all of them are decreasing, and I only see one right here, decreasing. So what that tells me, my x value for where it's decreasing is 3, and then 5. So my notation is going to be 3, 5. Now looking at the next one, it says determine the intervals on which the function is strictly increasing. Increasing. Well, I have it increasing right here, and then I have it also increasing right here. Looking at that, let's look at this one right here. This line segment is to be more specific of what it would be called. Is that I have it at negative 7, and then it's increasing all the way to negative 3. Again, 7, negative 7, and then it's increasing to negative 3. So my notation would be negative 7, comma, negative 3, but I'm not done yet. And I'm not done yet because we have another segment or line increasing right here. So this point is at negative 2, and it's increasing, and it's going all the way to 0 on my x-axis. So my notation would be comma. It said to separate with commas. -2, comma 0. And that's where the function is strictly increasing. Finding local maxima and minima of a graph given the graph, of a function given the graph. There we go. We have seen our local maxima and minima before. This is where you saw the words of and at. And if you remember correctly, I had you remember what the word of represented and what the word at represented. But if you need a refresher, what we classified as local maxima, that represented my hills, right, or mountains. And then the local minima, if you remember correctly, was the valleys. What we have over here, it says identify all local minimum values of f of x, the graph to the left. So that's key right there, right? Is local maximum values of. And what does of represent? That's my y values. You have to memorize that. Well, my local minimum, forgive me. Where are those at? Those are right here. Again, your minima is your valleys. And I'm going to be looking at the x values, or forgive me, the y values of each one. The reason why I'm looking at the y values again is because I'm looking at the word of. So that's at -3, -3, comma 0. Well, for the next one, it says identify all values at which f of x has a local minimum. So we're still at local minimum, but it's saying the word at. What does at represent? Our x values. So basically, we just want to find the x values of those 2 points. So it's at -2, and then for the minimum here, we're at 3. So -2, comma 3. Okay. The next one states, determine the intervals on which the function is strictly decreasing. I was reading the wrong one. I read the one below it. So I want you to do that one on your own. We did that right above for increasing and decreasing already. And then this one has you increasing. So go ahead and do those ones on your own. Again, we had done those above. The only thing I want you to note here is that right here you have arrows. So this arrow represents negative infinity, depending on what you're looking at. And then this is positive infinity. So you're going to have to utilize the infinity sign in your solutions there. And we'll cover those in class. Here it says finding x and y intercepts given a polynomial function. If you notice, this says review, meaning we have seen this before, but let's go ahead and do it again. So I have f of x equals 2x to the third plus 12x squared plus 16x. Well, the first step on what I want to do is find my y-intercept. And if you remember, to find our y-intercept, what we need to do is set x equal to 0. So let's do that. I have y equals 0 to the third power plus 12 times 0 to the second power plus 16 times 0. Well, 0 to the third power is just 0. 2 times 0 is just 0. Plus 0 squared is just 0. 12 times 0 is 0. Plus 16 times 0, 0. Thus, my y equals 0. That one's easy. and I'm going to shrink it just because we're going to need some space for my x-intercept. So for our x-intercept, what I need to do is set my y equal to 0. Basically this part is going to be set equal to 0. So let's do that. I'll have 0 equals 2x to the third power plus 12x squared plus 16x. Well, what we want to do, I want to do this in a different color. What we want to do is factor out our greatest common factor. So factor out a greatest common factor. So looking at this, I have 2x to the third power plus 12x squared plus 16x. My leading coefficient is greater than 1. It's a 2. And I want to see, can a 2 be factored out of 12 and 16? It can. Not only that, but an x variable can be factored out of each one as well. So my greatest common factor is 2x. What I get from there is once I factor that out, I get 0 equals 2x. Once I factor out that 2x out of the polynomial, I'm left with x squared plus 6x plus 8. And this is something we've seen before, and these are all steps that we've done in the prior sections or even prior chapters, specifically chapter 3, I believe. I can factor my c out. So let me label these A, B, and C. This is where you want to utilize that x method that I was showing you. And since my leading coefficient is 1, I'm just going to have 8 here and then 6. And remember, I want to find two numbers that multiply to give me 8 and add together to give me 6. Well, 4 times 2 gives me 8, and 4 plus 2 gives me 6. What I'm left with then is 0 equals 2x, x plus 4, then x plus 2. From there, what we want to do, and if you remember, is we want to set each part with an x equal to 0 and then solve for x. So we have 2x equals 0. We have x plus 4 equals 0. And then we have x plus 2 equals 0. And let's solve for the value of x. So x equals 0 there. I'm going to minus 4 to both sides. X equals negative 4. A minus 2 to both sides. And x equals negative 2. Thus, my x-intercepts are 0, negative 4, negative 2. And there you go. So it's kind of taken a little bit of what we learned in prior chapters and combining them all together here to find not just our y-intercept, but our x-intercepts as well. Again, that's the x-intercepts and y-intercepts. Go ahead and do B on your own, and we'll cover it in class. Just a heads up on that one, you'll have to do it by, on your x-intercepts, you'll have to factor by grouping, which we've done before. We've done factor by grouping. So I just want to kind of set you up for success there. Moving on, it says, remember you can tell the degree of a polynomial based on, again, degree of polynomial. That's your key term there, is your largest what? What was the degree that we learned before? Largest exponent is what you should have been thinking, and hopefully were. Now, going a little bit further with everything, a polynomial of a degree n has a maximum of n minus 1 turning points, or local extrema. And then it gives us like an example here. For example, if a polynomial has 3 turning points, then its degree must be an even number, or excuse me, an even degree of 4 or higher. So for example, the even degrees would be 4, 6, 8, 10, etc. And looking at number 4 here of inferring properties of a polynomial function from its graph, we're given the graph here, and for the sake of kind of understanding, let's do this. Let's make arrows here, just so we know that the graph's going on forever. Again, if you're confused where I wrote those, the arrows are right here and right here. You'll want to put those in your notes. The question or what's being proposed here is identify the intervals where the function is strictly decreasing. So decreasing. Okay, well, where are we decreasing at? Well, we're decreasing from here to here. We're decreasing from here to here. And we're decreasing from here to here. And what I'm looking for is the intervals, the x values of where I'm decreasing. Well, I'm here on an arrow, so that's negative infinity, right? Let's do it in red. Negative infinity, comma, and then I'm going all the way down because I'm decreasing, and what's the x value for that? Negative 2. Separation by a comma, and we're going to do the same thing all over again. Where am I at right here as I'm decreasing? I'm at 0 on the x-axis, and then I'm decreasing, and now where I'm at, 3, positive 3, comma, I'm decreasing once again, so I'm right here. What is that? 5, comma, 7. There we go. Now what we have, it says at which x values does the function f of x have local maxima? Local maxima. Well, there's some key words here. X values, local maxima. Well, where are my local maxima at? Those are the hills or mountains. That's right here, and then right here. Well, what are the x values of those 2 points? 0 and 5. And the next question that's being proposed is, what is the sign of the leading coefficient of f of x? And this comes from our prior section. Our leading coefficient, what is the sign? Meaning it's asking us if it's a positive or a negative sign. Well, if it's positive, what we'd want to see is our arrows going up like this. The question is, do we have that? Well, we do have that. Look where our arrows are pointing. Arrow pointing there and an arrow pointing there. So it's giving us almost like a parabola-looking shape, and I'm doing air quotes for that. But we see it's going in a positive direction. Thus, our leading coefficient of f of x, the sign will be positive. And then now we're getting kind of the nitty-gritty here of what are the possible degrees of f of x. Well, if f of x has 5 turning points, let's count them. 1, 2, 3, 4, 5 turning points, then the degree of f of x could be anything greater than 5. So let's write this out. If f of x has 5 turning points, then the degree, and please hopefully your handwriting is better than mine, your degree of f of x, what are the possibilities? Well, they could be 6, 7, 8, 9, etc. And again, this goes back to the point that we're making up here. A polynomial of a degree n has a maximum of n minus 1 turning points or local maxima. And it gives us an example. If a polynomial has 3 turning points, then the degree must be an even degree of 4 or higher. So 4, 6, 8. So our turning point was 5, and so our degree could be 6, 7, 8, 9, etc., etc. Now we're moving on to 4.6. This is something you've done before. It's just a lot of work at the end of the day. Kind of busy work. So it says pick one of the 2 expressions below to multiply. I'm going to do letter A, and I want you to do letter B on your own. So the first step we want to do is look at our what we have. So we have 4 plus 3y, and then 6 minus 12y plus 9y squared. And it's telling us to multiply. Well, we want to use the distributive property here. So we're going to multiply 4 to the 16, 4 to the negative 12y, and then 4 to the 9y squared. So let's go ahead and do that. And I'll do it long form just so you know what I'm talking about. 4, and then we'll have 16 minus 12y plus 9y squared. And then we're going to, and I'll do it in blue, we're going to do the 3y to the 16, and then to the 12, and then to the 9. So it's a positive 3y, and I'm going to multiply it to the 16 minus 12y plus 9y squared. Now let's go ahead and do that math. So here, 4 times 16, that's 64. 4 times negative 12y is negative 48y. And then 4 times 9y squared is plus 36y squared. 3y times 16 is plus 48y. 3y times negative 12y y gives me negative 36y squared. I was jumping ahead in my thinking. 3y times 9y squared gives me a positive 27y cubed. It is cubed because, again, the bases are the same, and we learned that in exponent rules, that when the bases are the same, you need to add the exponents. Well, from here, what we want to do is, and put this in your notes, I'll do it in a different color. Let's do it in green. We want to combine like terms. Combine like terms. So let's go ahead and do that. Let's kind of put everything next to each other, and I think it'll help to visually see where the like terms are at. So I have 64 minus 48y plus 48y plus 36y squared minus 36y squared plus 27y to the third power. All I did there was I just reorganized the expression, and I put the exponents in ascending order. So I went from 1 to 2, then to 3. And what that does, it helps me package it in a way to see what cancels out or what I need to combine. So negative 48y plus 48y, those cancel. 36y squared minus 36y squared, those cancel. So my solution, or my expression, is 27y to the third power plus 64. And that's my answer. So again, all we did was really utilize the distributive property and then combine like terms and came to our solution. So go ahead and try letter B on your own, and we'll cover it in class. So this says, with someone around you who worked on the other problem, discuss patterns between the two problems. We're going to go ahead and skip that. And then it says, consider how the answer is related to the terms in the problem. So looking at sum of cubes formula, the formula for that, and what you're going to need to know, is a to the third power plus b to the third power, or cubed, equals a plus b, in parentheses, a squared minus a times b plus b squared. And then it goes into difference of cubes. Again, when you're looking at sum, what that means is addition. When you're looking at difference, subtraction. So it's the same formula, we just change the signs. A cubed minus b cubed equals, instead of a plus b, it's going to be a minus b. And then it's going to be a squared plus ab plus b squared. Okay. Now let's utilize these formulas that we just been given and some examples here. So number one says factoring a sum or difference of two cubes. Well, this one, I need to wonder, is it sum or is it difference? This one is difference of cubes. And again, I know that because it has a minus sign. It tells me that it's the difference. Well, let's break this out. 27u to the third minus 125. Well, what that would equal, what's a cube root of 27? Is 3. And it says u to the third power. That's just u to the third power. Right? If I distributed that exponent of 3 to the third power is 27. U to the third power is u to the third power. From there, minus, well, 5 to the third power is 125. So what I want to do there, and if you kind of zoom in carefully, and I'm going to minimize this just a little bit, is what this represents here, and to kind of make the connection to our formula above. This is going to be my A, and this is going to be my B, okay? So let's do that. I'll do it in a different color to separate the steps. So it's A cubed plus B cubed, but I'm doing the difference of cubes, so it's going to be A cubed minus B cubed. Well, my A is 3u minus, what's my b? 5. And then what is my a squared? That's 3u squared plus a times b. Well, that's 3u times 5 plus b squared. That is 5 squared. So again, we're just taking what my a represents and plugging it into the formula. And then we're taking what my b represents and plugging it into the formula for all the letter b's. That's all we're doing. Just a matching game. Well, let's go ahead and simplify everything. And this is going to be our solution here that's coming up. I have 3u minus 5. And then 3u squared. And forgive me, I did make a mistake here. There we go, 3u squared. That's correct. That gives me 3 squared is 9. U squared is u squared. Plus 3u times 5 is 15u, plus 5 squared is 25, and that's going to be my solution. So really, at the end of the day, it might seem difficult. I think the most difficult thing is knowing the formula. From there, what you want to do is have just a matching game of matching the A with the A and the B with the B, and then from there, simplifying, and you're good. You're going to do letter B on your own, but if you notice, there's a 1 in front of that x value, x cubed, and this is going to be the sum of cubes. sum of cubes. So you're going to want to utilize this formula up here and match everything up. Moving on here, it says factoring review. So again, this is something that we've seen before. I'm going to set it up for you, and then I want you to solve it. We need to get this to be set to x squared minus 7x, and this is going to be plus 10 equals 0. And I'll go ahead and actually just do this one, and that way you could do the next one on your own. I noticed that my leading coefficient is 1, so I could do my x here. And this should look familiar. My c is 10, and my b is negative 7. Yeah, negative 7. So I want to have 5 times 2. Well, these both need to be negative. So I have x minus 5, x minus 2. Set both equal to 0. X minus 5 equals 0. X minus 2 equals 0. You add 5 to both sides, and I'm going fast because we have done this so many times. So I have x equals 5 comma 2, and then that's going to be your solution. So if you do y squared minus 37y plus 36 equals 0, you just want to check your leading coefficient here is 1, and so you're going to do the exact same thing we did over here, except if you notice it's already set equal to 0. Okay, it's already set equal to 0. Okay, we're going to be doing the same thing again here, but the only difference is that we're going to be left with possibly some answers with a square root sign. So I'm going to do one of them, and then I want you to do the rest of them on your own. So if you notice, I have x to the 4th power minus 7x squared equals negative 10. Well, let's bring that negative 10 over to the left-hand side. I have x to the 4th minus 7x squared minus 10 equals 0. Well, what I want to do here is I want to utilize my c and b. So let's do this. Maybe this will make sense a little bit. My c, and forgive me, that's a positive 10. My c is 10. My b is negative 7. So what is it? 2 times 5 gives me 10, but I need it to be a negative 7. So make those negative. What I'm left with is x squared minus 2. And then x squared minus 5. From there, you set both equal to 0. So x squared minus 2 equals 0. X squared minus 5 equals 0. Again, don't be confused by the x squared. That used to just be x, right? What we saw before was this was just x minus 2, and I would get x equals 2, right? And then x equals 5 down here. But we know how to get rid of that square root of 2, or the exponent of 2. We're going to add 2 to both sides, and I'll show you what happens. Let's add 5 to both sides. X squared equals 5. What we do is, you see how you have the exponent of 2 there? Exponent of 2. To get rid of that, what you need to do is you want to take the square root of both sides. And by taking the square root, what you're left with is x equals plus or minus the square root of 2. X equals plus or minus the square root of 5. So your solution for your x is equal to square root of 2, comma, negative the square root of 2, comma, square root of 5, comma, negative square root of 5. And that's going to be your solution. What I'm going to do is give you the solutions to the other ones, but I want you to do the work on your own. I just want you to be able to check your answer. So for letter D here, it's y equals 1, negative 1, 6, negative 6. And then the solution for E is x equals 1, -1, 4, -4. And that way you can check your solutions for that one. And lastly, y equals 2, -2, 4, -4. And those are going to be solutions. You just need to do the work on them. From there, that is the conclusion of chapter 4.5 and 4.6. Thank you, everyone.